Hello, this is Theophilus Braimoh here with Newton Academy. This is a cybersecurity course, and today we're covering Module 1, Intro to Cybersecurity. Now, on the agenda for today, we have Understanding Cyberspace, Communication and the Web, the Advent of the Internet, and at the end of the module, in order to test your knowledge, we'll be having a short quiz. Now, let's look at Understanding Cyberspace. What is cyberspace exactly? Cyberspace is a virtual environment where digital communications and interactions can occur. This can take place on a global network of interconnected computer systems. This can take place on the internet. It can also take place on social media platforms, online communities such as Reddit or forums, or any other type of digital space where data or information is exchanged and interactions can take place. We'll further look at communications and web technology. Let's look at a client. A common example of a client is a web browser, which is an interface or application that requests information, usually from a server, and displays web content. Now, this is made possible through the use of HTML, CSS, or JavaScript in order to render the web pages. And common examples of web browsers today are Safari, Chrome, or Firefox. A client can also look like a device, which is any internet-enabled appliance, such as a computer, smartphone, or tablet that can run a web browser. For example, we have the iPhone series, the Samsung S series, or Google Chromebook. Let's further take a look at servers. Now, a common type of server is a web server. A web server is a computer that stores, processes, and delivers web pages to clients. You often see this in streaming applications such as Netflix or YouTube, and it delivers HTML files, which are otherwise known as web pages, images, or videos to the client. In this implementation, we have a web server delivering directly to a client, but there are many other ways in which these kind of network topologies can be delivered. This is just an example for now. Another type of server is an application server. Application servers can host web applications, they can execute the backend logic, interact with databases, and generate dynamic content in order to send back to the web server. Now, dynamic content is important because we have information that is constantly needed to be updated on the fly. And when you have applications that are needed to be up 24/7, it is important for the app server and web server to work in tandem in order to provide this availability. This means that the app server, through encrypted means, will have the keys necessary in order to access the web server in order to distribute this information. Lastly, we have a database server. Database servers store the data that web applications need in order to work properly. They respond to queries from the application server and they manage data storage and retrieval. In the previous slide, we had the app server interacting directly with the web server. But if we add a database server in between, we can have the app server reach out to the database server looking for the admin credentials needed in order to dynamically push out content to the client. So the web server wouldn't need to store all the login credentials, but rather we have the app server, again, acting as an agent, performing all the automated actions which have been programmed beforehand in order to reach out to the web server and then push out information to the client. And here, of course, we have some servers which are currently in use in some data centers today. We have the Cisco UCS C series, the Asus RS series, and the HP ProLiant DL series. Let's now cover some protocols. The first two protocols we'll be covering are HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol, while HTTPS stands for Hypertext Transfer Protocol Secure. Both these protocols are being used by the web browser in order to communicate with the web server. However, HTTPS is the secure version of the two, which encrypts your data for safe transmission. If you've ever been on an HTTP website, chances are you get a notification stating that your data is being transmitted in an unencrypted channel. Thereby, it is recommended that you go to a website that does have HTTPS because it affords you with the peace of mind knowing that your data is not being sent in the clear, which is vulnerable to a man-in-the-middle attack. Now, a man-in-the-middle attack is a vulnerability in which data is intercepted between the web browser and the web client, but we will cover that more in a later module. Another type of protocol is TCP. This stands for Transmission Control Protocol. It is a connection-oriented protocol, meaning that first, before data is sent over the network, a connection first needs to be established between the sender and the receiver. This makes the data transmission reliable, ordered, and it has error checks in order to make sure that data is sent and received properly. In contrast to TCP, we have UDP, which is User Datagram Protocol. It, on the other hand, is a connectionless protocol that allows for the transmission of data without first establishing a connection between the sender and receiver. This makes UDP faster than TCP. However, it does not guarantee reliable delivery. There's no ordering, and there's definitely no error checking of data. So we do not know whether the receiver has received the information that we've sent across the network or not. In the diagram below, we see the differences between the two. In TCP, we have the slower but more reliable transfer of data, and is usually used in typical applications such as email or web browsing, while in UDP, we have fast but non-guaranteed data transfer, which means that the receiver is not guaranteed to receive the data that we transmit across the network. And we usually see this in applications such as voice over IP or music streaming applications. Now we also see the myriad of ways that data is being transferred across the network. We see TCP operating in the unicast method, while UDP has the options to perform in unicast, multicast, or broadcast methods. Another protocol we'll be covering is Domain Name System, which is the DNS protocol. This translates human readable domain names into IP addresses that computers can use to identify one another on the network. Let's now take a look at the brief history of the internet. We have the early history, which spans 1950s to the 1960s. We have the development of packet switching, which is developed by Paul Barron and Donald Davies. Now, packet switching is a concept in which data is broken apart into small individual packets and then transmitted independently across the network. When they are received at the destination, they are then reassembled in order to make sense of the whole thing. We also see the development of ARPANET, which is the U.S. Department of Defense project, which is funded in 1969. This allowed multiple computers to communicate on a single network and also demonstrated that packet switching is actually useful when applied in a network setting. Then, during the 1970s and the 1980s, we see the development of the TCP/IP protocol suite. This was developed by Vint Cerf and Bob Kahn. TCP/IP became the standard for communication on the ARPANET, but let's not count out the other inventions during this time. In the 1970s and 1980s as well, we see the development of NSFNet, which is the National Science Foundation Network, and BITNet, because it's Time Network. Furthermore, in 1971, Ray Tomlinson developed one of the first killer apps called the email program, which ran on the ARPANET. Then we have the birth of the modern internet. In 1983, the Domain Name System protocol is introduced, which allowed users to access websites by typing in domain names instead of IP addresses. This made the internet more user-friendly and accessible. In 1989, Tim Berners-Lee, a British computer scientist, invented the World Wide Web. He also created HTML, HTTP, and the world's first web browser. The World Wide Web allowed users to access and share documents through hyperlinks, making the internet more intuitive and easier to navigate. Then we continue on with the birth of the modern internet. In the early 1990s, we see the commercialization and growth of the internet as widespread use becomes more common in the general public. We see the introduction of web browsers such as Mosaic and Netscape Navigator, and Mosaic is important because it was the world's first graphical web browser, which means that pictures were included along with text in order to make the internet more intuitive. Then we have the modern internet and beyond, from the 2000s to present day. We have Apple changing the culture with the iPhone in 2007. We have more broadband networks being introduced into more remote areas, and this made the internet more available to almost everybody in the world because we have cell phone towers enabling internet access from almost anywhere. We also have the rise of cloud computing in the late 2000s, which allowed for remote storage, processing, and management of data. This led to new services and applications popping up everywhere, from streaming to big data analytics. We also have the rise in the concept of IoT, which allowed everyday devices to be connected to the internet, from smart thermostats to wearable technologies such as smartwatches. This created a more interconnected world on a personal level. And then we have social media, streaming, and e commerce booms happening in the 2010s, which see the rise of social media giants such as Facebook, Instagram, and TikTok. We see the explosion of streaming services such as Netflix and YouTube, and we see growth unlike ever seen before of e commerce giants such as Amazon and Alibaba. And that's it. That brings us to the end of Module 1. My name is Theophilus Braimoh. I'm here with Newton Academy, and thank you for watching to the end of this module. I hope to see you again next time, and please take care.